In this lecture, we discuss binary half adder. So in the last class, we have discussed the basic gates, all the gates we have discussed. Gates are the building blocks of logic circuits. Now here we are seeing, we will discuss the half adder circuit. Now this is the half adder circuit. It is an electronic circuit which is taking the two inputs, A and B, two inputs, and giving the two outputs. One is sum and another one is a carry. And at a time it is adding the two binary values. Now if I take my system, it is the 64 bit processor. Means what? 64 bits will move parallelly at a time. Now here it is adding only single bit. Now if I take 8 bit at a time, if I wanted to add 8 bits, then we need to add like this. So now here I am taking two 8 bits, A0 to A7 and B0 to B7. We need to take the values and it will give the sum from S0 to S7 and also carry, final carry. Now here it is adding only two binary values. So means what? If I am adding the 8 bits like this, 1011, 1001, 11000001. If my data is like this, then at the time, if I am adding the values, so how to add the values? For that we have an additive property. So what are those additive property? Property number 1, when you are adding 0 plus 0, then you will get the sum of 0 and no carry. And again, property number 2, 0 plus when you are adding, then at the time sum is 1 and no carry. And 1 plus 0, that time also sum is 1, no carry. And fourth one, when you are adding both ones, 1 plus 1, at the time we get 1 0. In this case, we are taking the 0 as a sum and 1 is a carry. Okay, these are the additive properties. Now if I am adding the 8 bit like this, at the time what? 1 and 1. If I am using the half adder to add, then here we are applying the 1 and 1, then it will add, it will give the 1 plus 1 means what? 1 0. So sum it will give 0 and carry it will give 1. But coming to the next, this carry is applied to the next binary value. But now this is a half adder, it will add only two binary values. So it will take AB. So 0 plus 0 it will take and it will give the sum 0 and carry 0. It is not considering the carry which is generated by the first binary. So this is the drawback of the half wave, but we need, this is a basic adder circuit, so basic circuit, that's why we need to learn what is half adder, and after that we go to overcome this drawback, to consider the carry, we are going for the full adder, that we will study in the next class. Now first let me explain the half adder. It will take only two binary values. When it is taking two binary values, how it is generating the sum and carry, that we will see in this lecture. Now let me draw the truth table for the half adder first, and after that we will see how to construct the diagram. Now truth table for the half adder. Here how many inputs are there? Two inputs are there and two outputs are there. What are those inputs? A and B, and outputs are sum, carry and sum. And because two inputs are there, we get the total 4 combination, that is 2 to the power of 2. 4 combination we get, that is 0, 0, 0, 1, 1, 0, 1, 1. Now for this, what is sum and what is carry, we need to calculate. Now if I take 0 plus 0, then I will get sum is equal to 0 and no carry is generated, and 0 plus 1, sum is 1, no carry, 1 plus 0, sum is 1, no carry, 1 plus 1, at the time we get 1 0, means what? Carry is 1 and sum is 0. Now this is the truth table for the half adder. Now from this we need to construct the logic diagram. So for that what? Now I need to derive the expression for the sum and carry. For that, by using this truth table also we can write the expression, but the procedure is using K-map. If we derive the expression, then we can easily minimize. So that's why I use the K-map. Now by using K-map, let me derive the expression for the sum. Now here two variables are there, so I need to take the two variable K-map, A, B, 0, 1, 0, 1. Now where we are getting the logic 1, there we need to know, here A is A bar and B. A is 0, B is 1, that time we are getting the A is 0, B is 1, that time we are getting the sum. Again A is equal to 1 and B is equal to 0, we are getting the sum. Now here we can't map these two, so that's why we need to write the expression for this directly. So S is equal to what can we write? A bar B plus A B bar. Now this also we can rewrite as A exclusive or B. Now similarly we need to derive the expression for the carry. Now same again I am taking the two variable K map A, B, 0, 1 and 0, 1. Now where we are getting the carry? For both are 1, then only we are getting the carry. So A is 1, B is 1, then we are getting the carry. So here carry C is equal to A, B. Now we got the expression for the sum and we got the expression for the carry. Now we need to construct the logic diagram. So logic diagram using XOR. First let me draw the logic diagram using XOR gate. This is first one. So now here I can take one exclusive OR gate and thereby what? We get the sum S is equal to A exclusive or B and carry is equal to what? A and B. We need to use one AND gate and here carry is equal to AB. This is one way to draw the diagram by using the exclusive OR gate. If we need to draw the diagram by using the basic gates, that time second one is what? Using basic gates. Basic gates are nothing but AND or NOT gate. Now here I am taking the A bar, this is A bar, B bar. Now what is the expression here for sum? A bar B. So A bar B and in between, so here dot is there, AND gate we need to use A bar B and the next one is AB bar. A I am selecting and B bar AND gate. In between if you see for these two in between OR gate plus is there, means what? OR gate we need to use to get the sum. S is equal to what? A bar B plus AB bar. Now again carry AB. This is A and this is B, need to use one AND gate. So carry is equal to C is equal to AB. This is using the basic gate. Similarly we need to construct by using the NAND gates. Third one is what? Using NAND gates. This is most important. Why? Because all the digital devices are designed by using the universal gates. That's why using NAND gate is most important. Now here we are using, in the last lecture only we have seen that exclusive OR gate can be designed by using NAND gates. How many gates we required? 4 gates we need required to design the exclusive OR gate using NAND gate. So the same diagram here I am taking. Total 4 NAND gates we needed. This is A, this is B, and here we get the sum. S is equal to A bar B plus A B bar. Now what is carry? Carry is AB. Now here this is an AND gate. Here we are getting the AB bar. Now for this, if you apply one more inverter, then we get the carry. C is equal to AB. So this is using the half adder using the NAND gates. We can also construct this half adder using the NOR gates, that you take it as a homework and you try to solve. Now mostly we construct the diagrams by using these 3 methods. So thank you. In the next lecture we discuss the full adder.